Good morning, everyone. Welcome and thank you for joining us for this morning's water led by Teledyne ISCO's Product Support Specialist, Dennis McGinnis. If you have any questions or comments during the webinar, please utilize the chat function. Questions will be answered at the end. If we can't get to all the questions, they will be answered throughout the week by one of our product support specialists. This webinar is being recorded and will be shared with all registrants and attendees later on this week. At this time, I will turn it over to Dennis.
Good morning. Again, this is Dennis McGinnis in product support, and today we're going to talk about stormwater sampling. So let's get started. So at first here, we're going to cover the topics we're going to go over. And at the beginning here, we're going to go over the stormwater monitoring overview. We're going to talk about stormwater sampling, of course. We're going to talk about flow monitoring in those stormwater sampling applications, water quality monitoring, which is for like parameters, pH, turbidity, et cetera. We'll talk about that a bit. Sample preservation, keeping our samples cold while we wait to pick them up. And then remote stormwater monitoring, which is basically going to cover communications and control the sampler remotely. So things to keep in mind about stormwater sampling. Stormwater sampling is needed for regulation purposes or for permit. Sites are typically going to be in remote locations, and the timing of those storms for those samplings are going to be unknown. So that's going to be things we're going to have to try to come up with ways to address those issues. Other application issues is going to be debris, level conditions, and power needs for these sites, as well as the needs for different site-to-site visits, or every site's going to be a little unique depending on where it's located, et cetera. So we're going to try to help come up with ways to address those issues. So here's a list of regulations that are required, that require the need for stormwater sampling. The regulations are listed here as 1948 Federal Water Pollution Control Act, and from 1972 and 77 the Clean Water Act, and then 1987 added a non-point source pollution. So these are all things to keep in mind if you want to read about those particular acts. That basically is why we need stormwater monitoring. So things to keep in mind when performing stormwater sampling. All the sites are going to require periodic visits, and storms don't always occur at convenient times, so we're going to have to find ways to overcome that, as well as many permits state a maximum hold time for those water samples. So again, we're going to try to cover things that can fix those things. The water sampling some water sampling requires manual collection. Those are for oils and grease, quality assurance, and auditing. So some challenges to expect at your stormwater applications. First off, power for these remote locations. How are we going to power those? Whether they're going to be a small battery depending on its longevity, or if we're going to need solar panels with larger battery capacities. Sample preservation, how are we going to hold those samples at 4 degrees C so the biologicals do not die on us? Remote confirmation to let us know when the sample's been taking place, or if the sample's running, or when it's complete. So basically it's overall condition. And so some sort of confirmation to us to let us know what its current condition is and where it's at. And then of course, the ability to initiate a sampling remotely would be nice. It's not always required, depending if you've got things in place out in the field that will do it automatically. But having the ability to remotely do that, we can cover that as well. Debris from storms. That's going to be things that could cover over your sensor, if you're doing level measurement, we're going to cover that. And then because of storms, they can be flashy or quickly changing water conditions. So safety is always a concern there. You know, for site visits, if you get like a flash flood, those type of things, we want to keep those in mind as well. All right. So to start off with, let's talk a very basic stormwater sampling need. And that's going to be, you're going to need a sampler and something to trigger that sampler. So in this particular example here, we have a 3700 sampler with a liquid level actuator. And basically what a liquid level actuator is it's a small device that sits down by the water's edge, and you mount it at a particular water level. The idea is as the water comes up, the conductivity of the water basically shorts out a small little pin on the liquid level actuator. That enables the sampler. The sampler then, of course, here in the diagram, we have the strainer down in the water. It takes the water in, puts it in the bucket, and then you retrieve it when the storm is done. So this is a very basic stormwater application, just using a liquid level actuator and a sampler. To go to the next step up, we could do dual enabling sampling. So we're still using the liquid level actuator for our water level, but we can add a rain gauge as well. So with the addition of a rain gauge, we can actually see when the storm comes in and starts. But if we just go basically off the rain gauge only, the problem may be that we don't have enough water that covers over the strainer. So what the liquid level actuator does is it allows us to know that once the water hits it, we know we have enough water covering over the strainer so we can bring that water in and put it in the buckets. So here's some dual trigger installation sites, some examples. Here you can see we've got a portable sampler on the far left with a solar panel, a marine battery, and a rain gauge. And then you can see the line across the bottom there showing where the suction line and the liquid level actuator will be. The other ones as well, basically you can see the rain gauge on the outside. That's going to be your rain input, and then the liquid level actuators are all ran down by the water. So here's just some site examples. So with that being met, let's move on to a little more advanced. Let's talk about stormwater flow monitoring. So in this case, we're going to take the same rain gauge with a sampler, but instead of using something like a liquid level actuator, we're going to use a level measurement like a flow meter. In this case, the 700 series works with the 6712, and in this example here, we just have a bubbler. So the bubbler, while it can be used to measure flow, if you use Manning's equation or you got a weir or flume, for the most part, this can be just used as a level actuator as well. So when we're doing flow monitoring, the challenges we're going to have to meet is the high turndown. So measurement of low level applications as well as low velocity applications. So those things we're going to have to think about for these flows, because on a light storm, you may not always have a big storm where you have high levels and high velocities. So we have to be ready for those low applications. If we find a site that we can't necessarily measure at this point, you may earmark that to do more monitoring continuously at that site to gather more data. Because storms don't always occur at convenient times, and many permits state maximum hold times for those water samples. So these, again, are other challenges we're going to have to meet. So we have to meet those low levels and low velocities, and then we're also going to have to worry about maximum hold times for the water samples. With that being said, when we're talking about flow monitoring, we always understand that there is no one single technology for every application. So for that reason, we have multiple technologies to help us conquer these difficult applications. Ultrasonic is one of them, bubblers, and area velocities. I'm going to spend a little bit of time on covering these in case you're not familiar with these technologies, but we want to make sure we have a good understanding of what these things do and how they work. Now, area velocity actually has a number of different technologies under them. There's a lot of different ways to do area velocity. So area velocity is basically the measurement of the area of the channel, how much water is in there, and then how fast is that medium moving. Timesing the area times velocity gives us our flow rate. So let's look at some of the equipment we offer that handles all of those different things. So we have the signature meter, we've got the AccuPulse, we've got ultrasonic, bubbler, area velocities, includes the LaserFlow as well as the continuous wave Dopplers. So this is pretty much our line that touches base. We have more, but I didn't have enough to show an entire slide of this stuff. So this kind of touches the base of common equipment you can use for stormwater flow measurement. So let's talk about operation of those actual flow measurements. So bubbler operation, pretty simple. Basically, you got a bubble line that sits down in the water, and what that bubbler does is it basically pushes an air line outside, and that water pressure that bubble has to push against is felt back at the pressure transducer inside the meter. As the water goes higher and lower, we increase or decrease the water pressure. Therefore, the transducer back at the meter knows how much water is actually in the channel. Ultrasonic. Ultrasonic transducer sits above the water. What it basically does is it transmits a sound wave from the transducer, hits the surface of the water, and it measures the time it takes to reflect back to the sensor. That shift, which is that detection of echoes, that shift lets us know the time the transmitted time it was received, how far that water is. So as the water gets closer or the water gets farther away, we know the level inside that channel. Now, one thing to keep in mind with ultrasonic sensors is they do have a deadband. And that deadband is the time needed for that transducer to basically listen for that return echo. What that basically means is the water level can never be within that deadband. So if the water level, what you typically do is you get your water level at the maximum height, and then you take your sensor and you move it above that point of whatever your deadband is. That's the closest your sensor should be to the water, is the water level should just come outside, just on the inside of that deadband, because you don't want it to enter into the deadband. Okay, so that's ultrasonic. Next is the continuous wave Doppler area velocity. So this is an area velocity sensor. It measures the area of water in the pipe, and it does that by using a level transducer. That pressure transducer measures the level inside that pipe, and knowing the shape and size of that pipe, we get the area. The next thing it does is it uses a Doppler signal, a sound wave, that shoots into the water. That signal bounces off particulates that are suspended in the water and moving with the speed of the water. So if we know how fast those particulates are moving, we know how fast the water is moving. We take all that information, we do an average, a weighted average of how fast the overall water is going. So we're getting lots of different velocities, but we got to come up with one value that says the entire mass of this water body is moving at this rate. So we do a weighted average, and with that, now we know the velocity. With the pressure transducer and knowing the size and shape of the pipe, we know the area times velocity, we get flow rate. Pulse Doppler technology, this is our Pro 20. What it basically does is it measures velocity a little differently. It actually shoots the velocity signal straight up in the air. So it's at the bottom of the pipe and it shoots it up. Now it is angled, so as that water crosses the channel, we're capturing 2 angles forward and 2 angles backwards. So it actually has to cross all those paths. So we can see those particulates enter into the area and exit the area, and therefore now we know how fast every point of those little lines are basically what we call bins. Those are sound waves that are basically shooting up, and we're capturing that velocity in those little areas. The level measurement is actually done by an upward-looking ultrasonic. So instead of my example earlier where we were shooting the sound wave down on the surface of the water and bouncing back, now we have a submerged Doppler signal that's basically shooting upward, hitting the surface of the water from underneath and coming back. So there's our level there. Knowing the pipe the geometry of the size and shape with the level that's in the pipe, there's our area, times that by our velocity, there's our area velocity. Skip gears a little bit here. I want to talk about the 6712 sampler, which is actually a portable version, and a refrigerated version, which we call the Avalanche. In those, we have those technologies, that bubbler technology, the 730 module, and the area velocity, the continuous wave Doppler module. So these modules, as well as the pH, they can all slide into the side of the 6712, so it's all integrated into one unit. This makes it so you're not lugging around multiple, sampler with a flow meter and a battery, et cetera. Everything's kind of compact and thrown into one little package. So this is some of that technology we just talked about, but it's in a smaller form factor that is easily for portability. Finally, I'd like to spend a little time on the non-contact LaserFlow and its benefits. Because this thing sits above the water, it does not come in contact with it, and therefore we are free from any debris that the storm may wash down. That's going to create minimal maintenance as far as the flow measurement goes. This also allows us to do non-confined space entry with the mounting hardware in place. So you do have to get in there and get the mounting hardware put in place for the first time, but you can do that under good weather conditions. And then, or when you have a lot more people there to help you out, but when you have one person going out there, that one person can actually mount this by himself. Now, I'm not suggesting you only have one person go anytime you're out of stormwater anyway. You should always run at least in pairs of 2 for safety concerns. But the idea is it is low maintenance. You don't, as far as maintaining it, you can pull it out and clean it up, put it back in, and for the most part, unless you get a surcharge condition, it should be debris free. This also helps against, because of the confined space entry with mounting it in place with permits, manpower, traffic control, all those only have to take place when you originally put it into the site. After that, because the mounting bracket's already in place, you can just lower it and go. It does a multi-point subsurface velocity measurement. So we're going to cover that a little bit, but a lot of words there. It basically say it measures velocity below the surface. And it has a wide operating range. It's capable of measuring very low and high flow rates. And of course, safety comes back into play again. The ability of not having to worry about being in confined areas or maybe in a unsafe location where you can do things remotely, like lowering down and grabbing the sensor and pulling it up to do maintenance, etc. That's all safety concerns that can be handled much better with the non-contact sensor. So let's talk about the operation of the LaserFlow. First off, it has two sensors in it as well. Kind of like the continuous wave Doppler, where it measures level and velocity. This does the same thing, it just does it differently. So to get the level measurement, it uses an ultrasonic level sensor. So it's non-contact. That gives us our level. Then we use a laser signal that shoots below the surface of the water. Now its focus point, then we can measure 5,000 readings of how fast that water is moving, and that is then reflected back to the meter. So our area measurement is with the ultrasonic, knowing the pipe size and shape. There's our area. The velocity is measured with the laser. Area times velocity gives us our flow rate. So a side view of this, how this operates, this can run up to 15 points, all the way down to a single point for velocity measurement. But at the end, we still have to measure level. Once the level measurement's done, we can select all 15 or any one of 15 or just a single point. But basically what we're doing is we're measuring velocities below the surface of the water and taking those velocities, timesing that by the area, and that's our flow rate. Okay, so now we've covered all the different flow measurement technologies in a real rough, quick way of how they work. And if you have more questions, you can always contact us more on that information. But I just wanted to touch base so everyone was on the same page and everybody had a good understanding of how the flow measurement technologies work. So with that being said, when you are doing a non-contact velocity measurement, basically this is the type of components you would need. You have a 2160, that's our portable version that handles the LaserFlow sensor, a 21.5 interface module. That's going to basically let that 2160 information get over to the 6712. The 6712, of course, is our sampler that will take the samples based upon the flow measurement from the 2160. In the center picture here, you can see we have a 2160 and a 2105 stacked. We have a modem off to the side, which we're going to cover later, hooked up to the sampler, and that's all in a storm box. The laser and the submerged probe and whatnot are all way down by the water. This is up top where it's a little safer to work with. And so here's an application of a non-contact. A few more pictures of a non-contact in action. Here you can see the sensors actually mounted over the pipe, shooting at the surface of the water and looking at the velocity coming down the pipe. Again, the center picture, lower picture is the same site, except you can also see that we have a solar panel there because it's a remote site, and we're going to have a laser out there. We want to make sure we have a lot of power out there to handle the sampler, the laser, the modem, etc. So here we have a solar panel with a marine battery running that entire site. Okay, so that is sampling with flow measurement. The next thing we're going to talk about is water quality monitoring with a sampler collection. So water quality monitoring requires the use of different sondes. So you have In Situ, you have Hydrolab, you have Eureka, you have YSI. There's a whole slew of different companies out there that do parameter monitoring. If they speak SDI 12 or Modbus, we can integrate those into our systems to measure those. Now the 6712, it speaks SDI 12 natively. If you have something that speaks Modbus, that can be fed into the 2105, which also speaks SDI 12, which is a very common communication protocol for sondes, for multi-parameter sondes. On the right here, you can see the young lady holding a YSI sonde. She's going to put that in the water, and that's going to run the sampler. And then they have a rain gauge off to the side they're going to mount. And so here, this is multiple measurements. They have, also you can see there's a 700 module on the side of the 6712. Looks like that's a bubbler. So they're going to have a level measurement, a rain gauge, and a sonde parameter to be able to take those samples all based on those conditions. Okay, so multi-parameter measurements include temperature, dissolved oxygen, conductivity, pH, ORP, turbidity. These are all things found in these type of sensors, and you can talk to your local reps as far as what sensors they handle and what would be best suited for your needs. But yeah, so these are different parameters that are typically recorded in different stormwater sampling applications. So if you want to do a standalone parameter monitoring, here you can use a 2105 and a sonde. We have a gentleman down here in the water right here. He's just got just a sonde hooked up to a sampler to take those parameters, or I'm sorry, not a sampler, but a flow measurement device. In this case, the 2105 interface. So it's actually just measuring parameter monitoring. There's no sampling going on here. No sampler. It's just monitoring those parameters. In this case, I also have a 2150 labeled here. So you could put a 2150 in there to get flow measurement with your parameter monitoring. Again, but there's no samples being taken. And then I have this little slide in here just to show if you're doing tidal influence sampling, it's the same equipment used for tidal flows. It's not, this isn't really covered for stormwater, but if you ever have to do any tidal flows, you'll notice there's a lot of the same things are required. You need a sampler, you need conductivity, salinity, those type of things, area velocity to measure flows in both directions because you want to see when the tide's going in and out. I just thought that was interesting when I was going through and looking into this type of stuff, that this was very similar and the same type of equipment needed for stormwater. So let's talk about sample preservation. Once the sample is taken, you can use ice for short duration sampling events, usually within less than 12 hours. For long-term use, you would need to have ice out there prior to the storm event. So you'd have to put that in place. So here's an example of having a sampler using ice to keep the sample cold. We want to keep that down to 4 degrees C. This can be difficult to manage, and it does expose your field crew to those hazardous weather conditions if they have to get out there a few hours before the storm starts to make sure your sample stays cold once it's taken. So as an alternative, another option would be to use the avalanche sampler. The avalanche sampler is a refrigerated 6712, and it basically uses a marine battery to power it, but the actual sampler is powered down until the first sample is taken. Then when the refrigeration cools the samples, it keeps them at 4 degrees C until it can be retrieved. Typically that's within 48 to 72 hours of the storm. So the refrigerated sampling, it's a lot more convenient, it's a lot more safer for your field crew, again, because they don't have to be out there just before the storm starts, may get caught in the storm, etc. This can just sit out there. It does require a lot more power because obviously you're using a refrigerator to keep those samples cold. Where on the portables, you're just using ice to keep them cold. But of course, there's obviously a lot more maintenance or human interaction there to make sure those ice is there before the storm starts. And also getting out there within 24 hours, well, 12 hours really, after the storm's done, so you can get those samples out there. Just depends on how much ice you have in there and what the weather conditions are. If it's cold or if it's warm, those are going to impact your ice needs. So power solutions. If you're doing a portable sampler, it's going to be a short sampling event. Again, you're going to be out there on the site within 12 hours to do the icing and whatnot. A small battery is not going to hurt you. However, if you're going to use a larger power needs for something that's more remote, it's not going to be visited as much, you're going to have the refrigerator, then a larger battery is going to be needed. And with that, a lot of times, solar panels are nice because if you're going to have them at these remote locations and you're going to have these batteries in place to run the sampler, the flow measurement, etc., the solar panel can keep those batteries up and operating ready for when the sample happens. Okay, so let's talk about wireless modem packages. So this is going to allow us to get information remotely as well as control the sampler, etc. So this is good. By using the remote applications for the modems, you're going to be able to not only monitor the current site conditions, but you're also going to see what the flow quality data is, any data logged in there as far as parameters go, and you're going to be able to get that from the remote location into your software. So that's all remotely without having to go out to the site and get them. Reduce site visits then, because you'll be able to see the site, you'll be able to go out there and look at it in your computer before even visiting the site to see did the sample get taken, if it did, when did it go, what are my power situation, if I have to replace the battery, So we get a lot more information without having to send somebody out there to get that. With those notifications that tell us when the sample basically was started, what its current status is, or when it completed, it allows us to wait until the storm is passed to go out and receive those samples. That's going to create a lot safer working conditions for your guys so they're not out there in the middle of the rain, or if the storm hasn't completed, or if they get out there in the middle of the storm, et cetera. This way they know the sample's done by the time they get there. So our wireless communication packages, we have them in CDMA and GSM. CDMA is basically Verizon, and GSM is AT&T for here in the States. For international users, you're all going to use GSM. There's a little bit of pockets of CDMA technology in China. Otherwise, GSM is pretty much the go-to for everybody outside the United States. With the modems, you're going to, as I mentioned before, you're going to be able to remotely retrieve that data with Flowlink. You can log in, download that data, have that data available to you without having to go out to the site. Also, it's going to allow you to remote program and take manual samples via a terminal emulator. So all this can be done remotely. Also, we have text alarms. So if you want to know when a particular level has been reached, or you want to know when the sample's complete, or if there's an error or a problem, we can get text alarms with that as well. So a little diagram of how this works. If you were to call in the site remotely, either with a terminal emulator or Flowlink, person at the computer basically calls out with the IP address to the sampler. The sampler then makes the connection, and now you have control of it. What that looks like in Flowlink is you can go to the measurement screen, and here you can see all the real-time data of that sampler on the screen. Here I can see the level, velocity, flow rate, the flow volumes going through. I can see at the bottom it says the sampler status. The program is running right now. It hasn't taken any samples, so it says 0 samples. And so yeah, all in one, I can see what my flow conditions are. If I had pH or turbidity, it would be showed up here as well. My rain gauge would be here if I had that on here, but I can also see what the sampler is doing at that moment in time. Now, this is just looking at real-time data. There is no control via Flowlink of the sampler as far as starting it, pausing it, disabling it, etc. If you want to have manual control over it, we can use a terminal emulator program. There's a lot of these on the market. Many of them are free. TerraTerm's one we use a lot because it's a free one, but you still have HyperTerminal, PuTTY, etc. What this allows us to do is by using the same IP address, we can log into the sampler. And from here at the very bottom, you can see if you type in control, you actually get to see what's on the front panel of the sampler as if you were out there. So here I can see the sample is actually disabled. So my storm event hasn't occurred yet, but I can see the real live data. I'm getting 5.9 cubic feet per second. I have a half foot of level there, and I've already accumulated X number of millions of gallons. Now I can also stop this program. I could force it to start. I could disable it. I could actually change the program parameters if I wanted to. So what the terminal emulator does, it gives us the ability to control the sampler just as if we were standing in front of it. So as an example of that, here you can see with the control, I'm actually looking at, I can pause it. It shows resume program, view data, grab sample, and pump tube alarm. Those are the exact same screens that are on the sampler at the moment in the field. So if there was somebody in the field sitting in front of it and someone was controlling it remotely, they would actually see those same commands being ran on their screen as what the guy remotely being seen. So it is it's basically a tether, a remote tether to allow you full control of that sampler remotely. So on the communication side, there's our looking at the live data. Here's controlling it. Now let's flip it around a little bit. Here's where the modem itself is actually sending the alarm out. So we can program the sampler for pre-existing alarm conditions. So if my level reaches, or my sampler becomes enabled because my liquid level actuator gets wet, or my sampler is taking its second sample, and I want to know when my samples are being taken, or my sample is disabled. All that can be done here. Basically, the avalanche sends the signal to the modem, and the modem can then send that information out as a text via the phone, or if you have, or if you set it up for emails, it can send an email to somebody as well. All right, so instant notification with the sampler. It will let me know when the sampler started, when the sampler is completed, when we have errors, any parameter limits programmed in the sampler, meaning I have my rain has met a certain amount, or my levels met a certain amount, or my pH has gone outside of a certain range. All these things can be programmed and notified on as an alarm condition. So there's a whole slew of different conditions you can put in to get those alarm conditions. All right, so that is the 6712 modem here. The 2105 modem does everything that the sampler modem does, but it allows you to push the data to Flowlink Pro. So the 6712 sampler modem that we were just talking there, where it does all the SMSs out, it can send an email out directly from itself, and it can be called up with Flowlink, and it can be initiated with a terminal emulator. 1205 can do all those things as well, but it also has the ability to push any data collected from the sampler to Flowlink Pro. And then if you have the optional Flowlink Global, you can get to that on the website as well. So the 1205 will connect with an Avalanche sampler or a 6712 sampler, and basically how it works is the Avalanche can then send its information out, which can go to the web, which is your Flowlink Pro. It can go to your phone, so you can send emails, or I'm sorry, you can send text messages out to those, but it also allows Flowlink to call into it as well. So here's a basic example of a remote sampler using internet-based communication with a 2105. It sends this information to the internet, it goes into the server. Once it's in the server, other people with Flowlink can now access that data. So this is all the data is flowing from the sampler to the modem, to the internet, to the server, and the people with Flowlink Pro can then access that information. On the flip side, once it's on that server, we can get that information out via the web. So you can have Flowlink Global out there, they can actually access that data, so you can be on site, you could be on a remote site, maybe in a hotel at night, wants to check his stuff before he leaves, et cetera, or maybe at home, he can look at all that with his computer or handheld with Flowlink Global. So on the desktop side of it, if we want to look at what that looks like, this is basically what Flowlink here is, logged in with Flowlink on a server. They can look at the data here. You can see, they download, they can look at the levels, the flow rates, the rainfall. If there were samples being taken, there'd be little squares there, the keys at the top. This is all with Flowlink at the desktop. On the flip side, the web interface will look something like this. This is global here. They can choose up to 4 different parameters to look at. So here they got level, pH, and overall flow. So this is a stormwater site here, and this is all remote via the web. So without the desktop, they can use this remotely. So remote notifications, a summary of what we've covered here. We can do text or email notifications from your water monitoring sites. We have remote access to collect the data. And with the remote access, we can program the sampler, which means we can trigger our alarms, we can tell it to take a sample, and we can change the flow pacing based upon the storm conditions. So in a nutshell, that covers our gambit of our stormwater sampling. We can do it with flow measurement. We can do it without flow measurement. We can do it with just a level measurement. We can, with a level actuator, we can take samples based on parameters of a SON. We can download the data remotely. We can get alarms when those things kick in, whether it be a level or pH or whatever, via a text alarm or an email. And we can contact that information remotely, download the data, look at it on the web, look at our desktop, et cetera. That goes the whole full circle of how we get the data out in the field, how we get it deployed, how we can gather the data, and how we can analyze it to know when we have to go back out and get the information, you know, as far as grab the bottles, take them to the lab, et cetera. That pretty much concludes my presentation. If you have any other additional questions, I'm going to be taking some questions here, but if you have more, we can, you know, point you towards contacting us directly. Here's our 800 number. Here's an email to the product support department. And so we'll take a few questions here.
We do have one question that's come in. Are you guys working for a Flowlink app for mobile devices?
Yes, we are. We are working on it. We do not have an ETA on it right now, but we are looking at a mobile device that will work on all applications. In other words, it will work on your Apple iOS as well as your Android. But I don't have an ETA of how long that's going to be when you're going to get those. So the answer is yes, but the other answer is I don't know when that's going to be available. So they're asking, can you direct connect can you connect directly to a 6712 via 2105 CI? Actually, you can. Now, with that being said, we can do that with a terminal emulator and control the 6712. We actually, in the 2105, I should say, in the 2105, when you log in with TerraTerm, there is a place for an ADFM connection. Now, the ADFM actually does a pass-through mode. And so by using that, we can basically piggyback the same information that we would talk to an ADFM, and we can actually go through the 2105 and talk to the 6712. Just like we can with the 6712 CI modem. Now, I will say you should use caution with this. As the menu states, it actually was designed for the ADFM to control it because it uses serial data input. The thing you need to keep in mind is because it wasn't designed for that, we don't have a lot of safety nets if you were to lose communication in the middle of that. So I'm always a little hesitant when I use a 2105 CI to do that. If that's something you planned on doing a lot, I would say go with the 6712 CI, the gray modem, because if we lose a connection there, we have things in place to drop the connection on the sampler end, so you could call it back. With the 2105, because it really wasn't designed that way, it was made for an ADFM just to go in through the serial, through a pass-through mode for the serial. It will work, but and it's a low probability, but if you were to lose communication during that time, the sampler would be stuck in that mode, in that communication mode, and that would require a site visit to go back out there, cycle power, remove power, and plug it back in to get the sampler back out of that state. So that's always a little concerning with the stormwater sites. I would say if you need to really do it and you feel confident with your signal strength at that location, go for it. I've done it many times without any problems. But I do think that the person doing it should know that there is a risk if you were to lose communication on the cellular connection while you're actually connected to the 6712 sampler before you dropped out, you may be making a site visit. So if the site visit is 2 or 3 hours away, you kind of have to outweigh your pros and cons. Yeah, I'm saving 3 hours, I'm not going out there, but if I get in there and do something really quick and get back out and I'm safe, good to go. If I left connection, I'm taking a 3-hour trip to go out there and recycle that power. So you want to grab the next one? It says the missing in the beginning.
Yeah, and just a reminder, this was mentioned at the beginning of the webinar, but this webinar is being recorded. So for those of you interested in a recording, it will be shared with all attendees and registrants later on this week. We will also have the presentation that Dennis has gone through available on the Teledyne ISCO website for download later on this week as well.
Okay. What is the deadband distance as a rule of thumb? Well, it really does depend on the sensor itself. But rule of thumb, pretty safe out there across the board, even with our equipment, is 1 foot. So 12 inches is pretty safe. I do know that there are some on the market that have a larger distance, which sometimes require a 2 foot. We don't have that, but definitely check with your ultrasonic provider as far as the specifications of what that deadband is. But usually 1 foot is pretty safe. And with our equipment, one foot should get you. So if you keep within 1 foot, you'll be all right. Do we have a purge pump?
Do you have to purge?
Oh, do you have to purge the pump? I'm sorry. Do you have to purge the pump? Actually, the pump is, yes, you do. It is actually built into the sampler. It will purge the line every single time. Then it will pull the water in, and then it will purge the water out. Now, the reason why we have that post-purge is because if water wicks its way up by sitting in that line, and it starts wicking its way up into the sample line, what ends up happening is when you go to take your sample, if you didn't purge that out, that water could be in there 2 or 3 hours before you actually take a sample. If you didn't purge that out, you would be bringing water that was just kind of sitting at the nose of that, or actually siphoned into the front end of that suction line into your sample. You would basically be contaminated with 2-hour-old sample. So we always do purge at the beginning to make sure any water that may have worked its way up gets out. Now, with that being said, you can get in there and you can change your post-purge counts. I think the minimum is like 10. So it would run very, very shortly before it went forward and pulled the water in. Of course, you'd always want to do a post-purge because you wouldn't want that water just sitting in there for the next sample, because then you would have cross-contamination. You wouldn't really be getting the sample you're taking now. You'd be getting the sample you took 2 hours ago. So Yes, you can. It does have to purge. You can minimize that, but I suggest leaving it as is to make sure you don't get any of that in there. Okay, so the next question is about Flowlink training. Do we have documents? We do have a document with a webinar, not a webinar, it is a database that has documents that go with it, that can walk you through it. I would say go ahead and contact us at product support, 866-298-6174, or at the email that I listed earlier, and I can flip that back. Oh yeah, I can do that. Let me just leave this up on the screen for you. There you go. If you contact one of us and just let them know you'd like to get the training documentation, I think that'd be the best way to get you trained on Flowlink. It does have, it's like 5 or 6 pages, and it walks you through. We have a database that goes with that, so it tells you which site to open. And going through that a few times gets you pretty familiar with that. Let's see. Okay, so the next question is, we have Flowlink 5.1 on their computer. They also have a Flowlink 4 with an RTD. It's an older RTD. They want to know if the RTD is compatible with the Flowlink 5.1 using the 700 module series. Yes, the RTD will plug into any of our samplers as far as the 6712, the Avalanche. It'll download the data. You can bring that back. Flowlink 5.1 still has ability to speak to the RTD. The RTD hasn't changed. So someone also asked, do I need a new RTD? No. The RTDs haven't changed technology. If at worst case, we have some bin files that we haven't needed to update in years, but if you have something that's really old, you could check the firmware in that, and we can get that updated as well. All right, what is the minimum depth required for the bubbler flow meter to work to collect a stormwater sample? Okay, good question. Really, in that case, the bubbler itself, the bubble line is really, really narrow. It's like only a quarter. So it's not going to need a lot of water to keep it submerged. But I think the question here is more about, because they're asking about stormwater sampling. The real key here is we need to make sure the strainer that the sampler is hooked up to is submerged. So with that being the case, that's usually about 1 inch. So I'd say you would probably want to make sure you don't turn the sampler on to about 1.5 inches to 2 inches, because when that pump kicks on, it sucks water in, and we don't want it to pull so much velocity, it pulls the head of the water down and starts gulping air. So I would say 1.5 to 2 inches would be a good level. Although, again, that's to tell the sampler when to turn on, so it knows that the suction line is completely submerged. The level as far as the bubbler goes is much smaller. It can go, you can put that on the bottom of the bed, and obviously it can measure all the way down to 0, but we want to make sure, the real main reason for having that there would be make sure that the strainer is submerged properly to take in the water. Okay. The next question is about the laser. They're basically saying the laser speeds of light. How do you control the distances to measure specific depths? Okay, so what we do here is the ultrasonic is actually playing multiple roles here. The ultrasonic sensor, while it is using the depth of the water to measure our area, so we know the pipe and size shape, and we know how much water is filled up in there, what that ultrasonic tells us is not only the level of water in the pipe for area calculation purposes, it's also used to let the laser know where to focus its beam. Now, in that slide I had where I had the 15 points, you saw it actually had 3 different depths. What that does is it measures at 5% below the surface. That's our first line. The second layer there is 8% below the surface, and then 11% below the surface. So we don't shoot the laser all the way through the entire channel of the pipe. What we're really looking for is those top layers of velocities, and by getting those, we can get a good, basically an average of what those velocities are moving at, and we can use that. So we take all the readings we take. If we use one, we use one. That's our one velocity we're working with. If we do multiple points, we then take an average of those multiple points. What we're trying to do is come up with, look, the whole pipe is moving. We're trying to come up with what's the best number to give us to tell us how fast this water is moving to go with our level measurement. So, let's see, I've got one over here. Will the Flowlink be available if we plan to use a 6712 with a third-party logger modem? The reason the modem is third-party is that we are adding a 6712 to existing system of level and turbidity monitoring. The system has an SDI12, and the logger is IRIS. I don't know what all that is, but that's okay. Okay, so basically Flowlink, trying to get Flowlink to work with another modem is going to be difficult. The modems that we have, the 2105 and the 6712 CI modem, they actually do, the 6712 actually handshakes with it. It opens that line of communication and works with it. So getting just any third-party modem, it could be very difficult. Now, I will state, if you can get a modem that has a serial data cross-through or talk-through tunnel, where basically you contact the modem, you establish that connection, and that modem allows you to do a cross-through, which is what I was talking about with the 2105. That pass-through of that serial data, then it would work, because all you're really doing is you're calling the modem's making a connection, then you're basically talking through that modem with a serial data connection, which is tied to our sampler's interrogator port. At the end of the day, Flowlink's on one end looking for the sampler, and the sampler's looking for that flow meter or that sampler, that Flowlink to come through. And so if you can get a modem that has that cross through, where it can just send the serial data through, then it would work. But I don't know if that modem does it or what third parties do. So you may be giving yourself a headache. I mean, I guess if you want to talk more at length with that, I'd say give us a call. Again, the number's on the screen, and we can talk more into it. But on this particular call here, I don't have enough information to know about that particular modem and whatnot, and maybe we could come up with another solution for you. So I don't have a definitive answer for that. Okay, the next question is, how is our 3G modem going? 1G to 3G. Well, actually, we're in right now on ours, as far as our generation of modems go. Our CDMA modems are currently at 2G. We don't have a 3G modem for our CDMA modems. I'm sorry, I was thinking of, I'm getting my modems mixed up. Let me start over. How's the migration of 1G to 3G going for the modems? Okay, we don't have any 1G modems. Currently, our CDMA modems, which is our Verizon modem, so to speak, they are LTE or 4G. Our GSM modems, they are currently at 3G. We are moving them to LTE because we're already seeing that transition. So as far as we're concerned right now, our CDMA Verizon modems, so to speak, are done. They are LTE 4G, they're good to go. As far as the GSM modems go, they are currently at 3G, and we are looking at moving them to 4G. Okay, one last question here before I'm going to call it. The last question here is, have you better addressed the huge power requirements of the laser? Yes, the laser does require more power than most of our sensors, and that is because it does, for its focus, it uses a train to move that sensor up and down. We have to focus that light underneath the water. That's our biggest thing, is that train of movement. As far as the power requirements go, the only thing we can really have you do for power requirements is reduce number of readings. Don't take 15 points, maybe take 1. The other thing is don't take your readings as fast. Instead of going every 5 minutes or 15 minutes, you may have to go at 30 minutes. So in the long run, the power that's required to make that laser go, it's set in stone. I mean, it's pretty much what it is. In order for this thing to operate and to give us the numbers we need, this is the power it needs to do these things. So all we can do is work with the constraints of what we can work with as far as how often do I take readings and how many points of data do I take. So it's a relative question, you know, huge power requirements, well, that's relative. Huge compared to what? Like a magnetor is much more actually, but we're not talking magnetors, we're talking lasers. Now we're talking lasers compared to bubblers, they might be on par. Bubblers use a pump motor. They take a lot of power also. So I don't know if I'd say huge power requirements. Again, that's all relative to what you're comparing it to. If you're comparing to like a submerged probe, absolutely. Ultrasonic, absolutely. But if you're comparing to like a bubbler, they're pretty much on par. Or if you're comparing to like a mag meter, pretty much on par. So unfortunately, the power requirements to make that laser work are what they are, but we can change some of the programming so it doesn't run as often, meaning not as many points and maybe not take as many readings, and we're good to go. We will have, let me think here. Right, so with that being said, on the laser, the other thing you want to point out is, other non-contact measurements only measure the 1-point surface velocity. So there is a pro and con here. For our laser, our pro is definitely, we're not measuring the 1 point on the surface, we can measure multiple points below the surface. But again, as far as power consumption goes, the power that it takes is what it is, but like I said, we can make adjustments to those readings to reduce those power requirements, but at the end of the day, I wouldn't expect us to see any major changes in the laser as far as trying to get what we need down farther, because we're pretty much right at our limit. We have to move that train to go out with to move back and forth. Now, if you didn't move that train, you only did a single point, obviously that's going to be less power. And if you're going to do 1 point of not only 1 point, but if you're not doing as many readings, it's less power as well. So there will be less power applications. When the EX laser comes out, when that gets released, that will be less power because it's a single point, or it doesn't do depth points. So it's a single point measurement. So inherently, that's going to be lower power in the fact that it doesn't have all those servos and motors it has to move because it's doing a single point. It's also going to be much more regulated to meet those EX or explosion areas. So it will be less power compared to the other one, but that's because of the way it operates.
Okay. Well, I think we've covered a lot in the last hour. So first off, I want to thank Dennis for his great presentation today. If you do have any further follow-up questions or things you want to discuss, please contact the product support department at the information listed on the screen currently. Again, just a reminder that this is being recorded and will be shared with registrants and attendees later on this week, along with the presentation being available on the website. I do want to let you know that we have 2 different water webinars coming up in the month of April. On April 18th, we will have a webinar introducing and providing more information on the LaserFlow EX. So be on the lookout for information on that webinar and how to get registered. And then on April 30th, we will have a deeper dive into the world of samplers, looking at the vacuum versus peristaltic pump sampler and which one is right for you. So be on the lookout for information on both of those webinars coming shortly, probably around the beginning of April. Thank you so much, everyone, for joining us today, and thanks again to Dennis, and have a great rest of your day.